Hi guys, welcome to the 34th video of this Love Babbar 450 questions series. So this sorting part we are doing, searching and sorting. And if you have not watched a single video, I'll share the link of the playlist in the description. You'll also find the question sheet link in the description. And you can also see it on CodeChef Discuss. Just type in Love Babbar 450 questions. It has got many views. It's quite trending. So thank you all for supporting till now. Please like, share, and subscribe. So the problems are becoming tougher and tougher right now. And I did not understand these two problems as of now, this Rasta and whatever, Shatak. And this kth smallest number, I don't know the exact solution to these two right now, but I will do it. I will do it later on. Whatever solutions I know, I will do it first. Whatever I don't know, I just don't want to read it from GFG and tell it out. So I will do it first, try to understand it. Maybe then I'll give a better explanation. So now let us do this problem today. It's quite easy only. Basically, we will be given the first term of an arithmetic sequence and we will be given the common difference. And we have to tell whether this term B is a part of this arithmetic progression. So arithmetic progression can be represented as a plus n minus 1 into d. Okay, this is the general term of an AP. This is what? This is general term of AP. This is 10th standard maths. I think you should know this. So a plus n minus 1 into d is the general term. So what equation we should be doing is, so first term is a, n minus 1. Now common difference over here they have told is C. So a plus n minus 1 into C should be equal to some B. Okay. Now there are many test cases and there are many base cases. We should look into all of them. How to look into all of them? What are they? First of all, if C is 0, that means common difference is 0. Then if A is equal to B, that means there is only one term, then we return 1, as we are understanding from this code here. Otherwise, we return 0. Actually, let me just copy this once and I'll paste it in my Sublime text. So look over here, okay? If C is 0, then there should be only one term. Then only we can say, okay, it is an AP. Because if there is a one term only, then it's AP only. Na? So if A equal to B, then it is one term. So it is 1, we return 1. Otherwise, we return 0. Otherwise, we have to just check for these two conditions. B minus A by C should be greater than or equal to 0. This value should not be negative. Why this value should not be negative? Because see, n minus 1 into C will be B minus A by C. So if this value is less than 0, then n plus 1 is less than 0. So if this value is less than 0, then what happens? N plus 1 is less than 0, n is less than minus 1 or something like that will happen, na? Which is wrong. N is a positive integer. So you just have to look into these two conditions, okay? I don't know why this question is in this list. It is quite a simple problem only. I don't know why, but I think you have understood now. And of course, B minus A mod C should be 0. Otherwise, we return 0 if all these conditions are false. So the example for this would be, just a small example I will take. For example, if first term is 3, common difference is 2. So what is the AP? It will be 3, 3 plus 2, 3 plus 2 into 2, 3 plus 3 into 2. What is that? 3, 5, 7, 9, something. So if suppose b is equal to 8, is 8 over here? No. So we return 0 like that. If it is 9, 9 is a part of the AP. So it is found here. So we return 1. We return 1. That's how we solve this problem. Nothing great in this. Okay. So that was this problem. Next problem is find the pivot element in rotated and sorted array. Can you see this? I think now you can, right? Find pivot in rotated and sorted array. So what is this pivot? So as far as I know, pivot is minimum element. Pivot is what? Minimum element. But in this, they have said it is maximum element. I don't know what is correct. Whatever I have read, I think pivot is minimum element. Well, let me tell you for this case then, when pivot is minimum element, what to do. For example, if the array is suppose 3, 6, 8, sorry, 4, 6, 8, and 1, 2, 3. If this is our given array, then pivot is 1 and index of pivot is 3. We have to return the index. So like this, we have to return. I have already done a video on how to find for an element in a rotated sorted array. That video is already there. Please go watch that. I think it's in part 29, 30 or 31. I'm not sure. But in the earlier part, I've done a problem, find the element in rotated sorted array. So you first see that. But how to solve this problem? Well, to solve this problem, so what we will do is, let us make a function pivot index and argument will be some array and length of the array. Now we have to handle what? We have to handle base cases. What are the base case? If n is equal to 0, then we return what? If n is equal to 0, what do we return? Maybe we can return 0, whatever. If a of 0 is less than or equal to a of n minus 1, this means array is not rotated but sorted. So if array is not rotated and but it is sorted, then the minimum element is at index 0 only, na? See, what I mean by that is, suppose the array is 1, 3, 4, 5. 1, 2, 3, 4, 5, okay. This is not rotated. There is no rotation here. So minimum element is at index 0 and it is sorted. So we can directly say it is 0. Pivot index is 0. Otherwise, what to do? Otherwise, let us say int L is equal to 0 and h equal to n minus 1. Now let us do binary search. While L is less than or equal to h, we say int mid is equal to L plus h minus L by 2. How to check for pivot element? So first of all, let us understand how to check for this pivot element. This pivot element will be, for example, if the array is 4, 6, 8, 1, 2, 3. See, when we are scanning through the array, we find that 4 is less than 6. Move to next element. 6 is less than 8. Move to next element. 8 is greater than 1. Oh, so if 8 is greater than 1, that means we got the pivot element. So what is the conclusion? Conclusion is, if we are at some index I, and if a of I is greater than a of I plus 1, if a of I is greater than a of I plus 1, this is pivot. Pivot index is I plus 1. So let us write that code now. If a of mid is equal to, if a of mid is greater than a of mid plus 1, then we return mid plus 1. Else what we should do, if this condition is false, what we should do in binary search, what we should do, either check on the left side or check on the right side. So only two more conditions are there. What are the conditions? What else will be the condition? Else if a of L is less than or equal to a of mid, if this condition is true, that means the left subarray is sorted. So we should check on the right subarray. Otherwise, right subarray is sorted, we should check on the left side. Checking on the right side is mid plus 1. Checking on the left side is h equal to mid minus 1. Ultimately, we should just return 0 if we don't get anything else. We should just return 0. Or maybe we return minus 1 or something else, like there is no pivot only or something. I don't know, but just return 0 only. So this is the binary search code, binary search algorithm to find out pivot element. So I hope you understood this, how to solve using binary search. Now I will see you in the next videos. Maybe we'll solve little more harder problems. And until then, keep practicing, keep learning, stay safe, and like, share my video with all your friends. Subscribe to the channel. It will really motivate me. And I'll take your leave now. Have a good day. Bye. Take care. Stay tuned.